pop function in set we use to remove and return an arbitrary element from a set. So when I say arbitrary, a random number, I do not know which element is to be removed, but we can get one element out of the existing elements in the set. So we can use the pop function by just calling on the respective set. For example, here we have taken a set S holding 1, 2, 3. Now when I'm calling the pop function on this set, so I'm going to get some random element removed out of this, maybe 1, maybe 2, maybe 3, and that element will be returned. So as a result, I can store that element within a variable. So which I'm trying to print here. So assume that 1 has been removed, so I'll be getting 1 here. So it is not guaranteed that only 1 can be removed. Any element randomly can be removed out of it. Now, if you apply the pop function on an empty set where there are no elements, then it is going to raise an exception which is called a key error. Now the next function, that is remove function, which is pretty much like your pop function, but here we can eliminate, you can remove a specific element. So in pop function we could see an arbitrary or random element is removed, but while using remove you can specify which element you want to remove from the existing set of elements. Now assuming we have taken a set here holding these 3 elements, I am writing set name followed by remove, and the element which I want to remove is what? 2. So after this is removed, when I am going to print my set, I am going to get the remaining element, that is 1 and 3. Now in case we are trying to remove an element which is not available in this list, so then you are going to get an exception, that is nothing but your key error. Discard function behaves like your remove function, except the fact that it is not going to raise any key error whenever the specified element is not available. So previously we could see when I am trying to remove some element which is not available in this list, it was raising a key error exception. But in case of discard function, it is also used to remove a specified element from a set. But if the element is available, of course that will be removed out of it. In case the element is not available, then there is no error or exception raised out of it. So in this example, let's say we have taken this my set holding 1, 2, 3, and I'm writing discard of 2. So I'm trying to remove the element 2 out of this because 2 is existing here. Hence it is going to give me the remaining element, that is your 1 and 3. Now in place of this 2, I'm going to write something 5. So 5 is not available in this set, but still I am not going to get any exception out of this. So that is the most important difference between your remove and discard. So clear function, as the name indicates, it is going to remove all the elements present in a set, irrespective of how many are available. So we can use a set name and upon which we can call the clear function. So assuming here we have a set holding these elements. Now when I am calling this clear, it is going to remove all the elements. As a result, what happens? Your set has become an empty. Now this clear function will not arise any error even if the set is already empty. There are no elements in the set, and then I am applying this clear function on it. Still, it is not going to raise any error. Now, union function is mostly used in order to return all the elements present in both the sets. So till now we have been using only one set upon which all the functions have been applied. Now when it comes to union function, you need minimum 2 sets. Let's say here I am writing x union y. So where x is a set, y is a set. Now let's see. We have taken x equal to this set of elements, y equal to this set of elements. So when I'm applying x union y, it is going to bring everything that is present in both of the sets. But if there are some common elements, they will be kept only once. So like you can see here, 30 and 40 are available in set x and the same also available in set y. So there will be no multiple occurrences because we understand set is not going to accept duplicate values, right? So as a result, this 30 and 40 are going to appear only once. Obviously, the remaining elements 10, 20, they are part of your X, and 50, 60, they are part of your Y. So all elements have been put together as a result of union. Now the same outcome we can also get in place of writing union function. You can also take this help of OR symbol. So if I'm writing X or Y, it is nothing but we can understand X union Y, which is the same set of results what we have got in the earlier one. Now intersection function is used to return the common elements present in both the sets. Now similar like we have called union, the similar way we'll call say some set X intersection followed by another set. Now we have taken the same set of elements in both the, in X and Y. So here we observe that when I'm going to write X intersection Y, it is going to find out between these two sets which are the elements which are common, which are present in both the sets. So we can see 30 and 40. These are the ones which are available in X as well as in Y. So as a result of which we will be getting the outcome like 30, 40. Now the same also you can achieve by replacing the intersection function with ampersand. Okay, so X and Y. This also gives me the same result what we have got out of this intersection function. Now the difference function we can use to find the elements that are available in one set but not in the other set. So like for example, the syntax is, let's say we have set 1, you are applying difference function on say set 2. So this is going to give me everything that is there in your set 1 but that is not available in set 2. So let's see an example. So let's say set 1 is having this 1, 2, 3, 4 and set 2 is having this 3, 4, 5, 6. So when I'm applying set 1 dot difference set 2, so we can see 1 and 2, these are the elements which are not present in your set 2. Hence, those elements are going to be the resultant of this difference function. So when I'm going to display this value of this variable difference, which is a set in fact, I'm going to get what? 1, 2. So if I'm going to write the reverse, let's say I'm going to write set 2 different set 1. So we can expect that 5 and 6 will be the output because these two values are not present here, whereas 3, 4 are present here, but 5, 6 is not, they're not present here. Hence I should be getting 5 and 6 for that. So symmetric difference function we use to find all those elements which are present either in the sets, either of the sets, maybe in set 1 they are present or set 2 they are present, but not in their intersection, not the common elements. Let's say when I'm taking these two sets, set 1, set 2, holding 1, 2, 3, 4 and 3, 4, 5, 6. So 3, 4, these are the elements which are the intersection of set 1 and set 2. So excluding these elements, whatever elements we have left in either set 1 or in set 2 together, they are nothing but the resultant of your symmetric difference. So when I'm going to print this value, sim difference, I'm going to get 1, 2, 5, 6, where 1, 2 were part of your set 1, 5 and 6 are part of your set 2. So set comprehension is the very concise way of creating sets from an existing iterable or other sets. So we can see the syntax is like we can take some expression for some variable in some iterable. So if possible, we can add some condition also. Now here I'm taking some numbers, some variable which is going to behave like a set later. Now we have taken x for x is in a variable in range of 1, 6. So the range function is going to produce 1, 2, 3, 4, 5. So every value of x in this range are to be added as a part of the set elements. So when I'm going to print these numbers, we are going to get the output as these 5 elements which can be of any order. Now we can use this set comprehension on various iterables. Maybe I can take the list. Here I've taken a range function. I can take a list tuple, or you can also take some other set from where you can create the new set.